but we called it something else. What did we call it? Substitution is one step of it, but we called it. I called it multiple unknowns. So if you have two unknowns, you need how many equations? Yeah, two unknown, two equation type problem, or multiple unknown type problem. In other words, system of equations, as they call it in algebra. Well, sometimes we'll have problems like that, and that is number 76. So let's quickly look at 76. The Fahrenheit and the Celsius thermometer are immersed in the same medium. At what Celsius temperature will the numerical reading on the Fahrenheit thermometer be 49 degrees less than that on the Celsius? So the Fahrenheit should read 49 less than the Celsius. At what temperature is that? At what temperature will the Fahrenheit be 49 less than the Celsius? That's one. Or B, at what Fahrenheit temperature will it be twice? So let's say the Celsius is 25, the Fahrenheit should be 50. Or the Celsius is 100, the Fahrenheit should be 200. At what temperature, if any, do we have that? Or C, 1/8 that on the Celsius thermometer. Or D, 300 degrees more than that on the Celsius thermometer. And so what we could do is we could put two thermometers side by side and see at what temperature they match. That would be the manual approach. That would be a lot of work, right, to make a thermometer like that. So instead, what we're going to do is we're going to try to solve this. But when you look at this problem, does it look like a dimensional analysis approach would work here? Does it look like an algebraic approach would work? The algebraic approach, the equation we had is degrees Fahrenheit is equal to 9/5 degrees C plus 32 degrees. And so if I want to know, okay, at what Fahrenheit temperature will the Celsius be double that of the Fahrenheit? Can I use this? No, because that's two unknowns. I don't know what the Celsius temperature is, and I don't know what the Fahrenheit temperature is. Hey, isn't that similar? That's very similar to what we saw before. I don't know how much chlorine solution to add because I need to know the total volume, but I don't know the total volume until I know how much chlorine solution I have to add, right? And so it's one of these situations. Well, that type of situation is what we call a multiple unknown, multiple equation type problem. And so we need two equations for this. And so let's do the first one. The first equation is the degrees Fahrenheit is equal to 49 less than the Celsius. So degrees Celsius minus 49. And so here, the Fahrenheit temperature is 49 less than the Celsius temperature. What is it? Do you know? No. And so what we need is we need another equation. And then we do substitution. And so what I'm going to do is I'm just going to go ahead and substitute that in here, let's say. Since this is already solving for degrees Fahrenheit, I'll just substitute. Degrees Celsius minus 49 is equal to 9/5 degrees Celsius plus 32 degrees. And then what I'm going to do is I'm going to get the degrees Celsius on one side. So I'm going to subtract 1 Celsius from both sides, so 5/5. So this is going to give me 4/5 left over. 4/5 degrees C, and then I'm going to add 49 to both sides. Oh, actually, no, I better subtract 32. If I subtract 32 from both sides, it's going to be minus 81 degrees. And then solve for degrees C. Degrees C is going to equal 5/4, 81 degrees negative. And so I'll do that. I get 5 times 81 divided by 4. 101.25. And so my degree C is 101.25. And so if I'm at 101.25 degrees C, then I just add 49 to that. That should be my Fahrenheit temperature. Right? And so let's go ahead and check that. 101.25 times 9 divided by 5 equals plus 32. And I get, well, I don't get it. I get 214.25. So I need to double check this. But we're out of time, unfortunately. So this is a third problem-solving method that we encounter. You know, dimensional analysis is by far the most common, followed by algebra, followed by this multiple